We're going to simplify this complex rational expression using the method that requires a single LCD of the entire expression, where we use this LCD to clear the denominators of the top and bottom. For starters, I'm going to find the individual denominators. It looks like x and x plus 4 are the only expressions that show up in any of the individual denominators. And since those have no common factors, I need to include both of them in my LCD. So my LCD is the expression x times x plus 4. That means I'm going to multiply this whole thing by x times x plus 4 divided by x times x plus 4. So I am multiplying by a ratio equal to 1, which is why it is that this is legal and we consider this to be an operation that doesn't change anything. Now, to simplify this, I am going to take the expression in the numerator and bring it in to both terms of the numerator of my complex rational expression. I am then going to take the expression here, the LCD that's in the denominator, and distribute it in to both terms of the denominator of my complex rational expression. But keep in mind that while I'm doing this, I'm only bringing one copy of the LCD. I'm not taking the whole LCD over the LCD into both the top and the bottom. It's just one copy at a time. So that, looking at the numerator first, I can see that I have a 1 as my first term. Since it has no denominator, nothing from it will cancel with any factors from the LCD, so I still have the whole LCD x times x plus 4. Looking at the second term, 5 over x, I see that I retain 5 from the numerator, but the factor of x in the denominator is going to cancel with the factor of x in my LCD, which I can demonstrate by bringing in my blockers here, showing these gray ovals indicate that the x in the denominator of 5 over x is going to cancel with the x in the LCD just while I'm doing this one computation. So I have 5 remaining from the numerator, and I have x plus 4 remaining from my LCD. I now go to the denominator and do the same thing. In my first term, I have 1. Nothing cancels, so again I have 1 times the whole LCD, x plus 4. And in my second term, I still have that 1 from the numerator, but this time it's the factor of x plus 4 that cancels. And so the factor of x is the one that remains. Again, I can visualize this with these little oval blockers so that this 1 in the numerator became this 1 right here, and this x in my LCD became this x right here. At this stage, we need to multiply these expressions out and then work toward factoring them to check to see if there are any common factors we can cancel out. There's a little bit of a shortcut here if we recognize the common binomial factor in this numerator. It works to factor this by factoring out the x plus 4 rather than multiplying everything out first, turning it into a trinomial, and then having to factor it from scratch. It will certainly get you the same answer either way, but if we happen to notice this common binomial here, then we can, in the next step, see that we're left with just this 1x plus 5 as our first factor. We'll call that x plus 5. And our common binomial x plus 4 as our second factor. We can go straight to the factorization if we happen to notice that. these little shortcuts don't come up very often, so that makes it a little bit harder to recognize them when they do show up. Down here in the denominator, we could factor out the x right away, but this one will probably be a little bit more straightforward if we go ahead and just distribute, combine like terms, and then factor it from scratch. I think it's less confusing this way, so that's what we're going to do. That becomes x squared plus 4x, and then we still have our plus 1x term here. So we now have two terms that can be combined. The plus 4x and the plus x will combine to give us plus 5x. So this whole thing is now x plus 5 times x plus 4 over x squared plus 5x. And we can now factor out the common factor of x from the denominator to get x plus 5, x plus 4, over, this is just a GCF in the denominator, x times x plus 5. So it turns out in this case we do have a common factor of x plus 5 that we can cancel out. And our final answer we can express as simply x plus 4 over x.